Okay, so we're going to continue on with some parabolas and tangent work. Okay, so the line y equals mx minus 1 is a tangent to the parabola y equals x squared minus 4x plus 3. Find two values for m. So looking for two answers here. Okay, so we know that tangents exist here, so discriminant's equal to 0. Let's make y equal to y. mx minus 1 equals x squared minus 4x plus 3. Let's bring everything across, make it equal to 0. So that will be mx minus 1 minus x squared plus 4x minus 3 is equal to 0. So it's minus x squared plus mx plus 4x minus 4 is equal to 0. Okay, so we've got multiple terms for x here, so to identify b, let's take out the common factor of x, bracket m plus 4, close the bracket, minus 4 is equal to 0. So a is minus 1, b, the coefficient of x, is m plus 4, and c is equal to minus 4. We know that the discriminant is equal to 0 since tangents exists in this case. So that will be m plus 4 all squared minus 4 times minus 1 times minus 4 is equal to 0. So that's m squared plus am plus 16. Then minus 4 times minus 1 is 4, times that by minus 4 is minus 16 is equal to 0. These two cancel and I've got m squared plus am is equal to 0. Take out a common factor of m, that will be m bracket m plus 8 is equal to 0, which gives me m equals 0 and m plus 8 equals 0, which is m equals 0 and m equals minus 8. Okay, next question. Find the equations, so plural, find the equations of the tangent from the given point to each parabola. So the parabola is y equals x squared, and the tangent passes through 0 minus 1. So if you think about a straight line that passes through 0 minus 1, well, we don't know its gradient, so that's unknown, but what we do know is the y-intercept is minus 1, so generically speaking that could be written as y equals mx minus 1. Now we know that tangents exist here, so the discriminant is equal to 0. So again, y equals y, x squared equals mx minus 1, x squared minus mx plus 1 is equal to 0. So a is equal to 1, b is equal to minus m, and c is equal to 1. Let's put that into the discriminant, so that's going to be minus m all squared minus 4 times 1 is equal to 0. So that's m squared minus 4 is equal to 0. That's the difference of two squares. M plus 2 bracket m minus 2 is equal to 0. And that will give me m equals minus 2 and m equals 2. That's my two values of m. So generically speaking, the tangents can be written as y equals mx minus 1, but I now know that the gradients are minus 2 and 2, so that's minus 2x minus 1 and 2x minus 1, and that's the two equations of the tangents. Okay, let's try another one. So find the equations, again plural, the equations of the tangent at the point 0, 1 to the parabola y equals minus 4x squared. So again, we know that the tangent, the straight line, or the tangents pass through 1, but we don't know the gradient. So generically speaking, we can say that the equations are given by y equals mx plus 1. So for tangents that exist, we know that discriminant is equal to 0 and y equals y as our approach again. So that will be mx plus 1 is equal to minus 4x squared. Let's bring that across, and that'll be 4x squared plus mx plus 1 is equal to 0. A is equal to 4, b is equal to m, and c is equal to 1. So it's m squared minus 4 times 1 is equal to 0. That's m squared minus 16 is equal to 0, difference to squares. Will give me m plus 4 bracket m minus 4 is equal to 0, and that will give me two results of m equals minus 4 and m equals 4, which gives me two tangents, y equals minus 4x plus 1 and y equals 4x plus